In this example, we want to describe the set of points that satisfies the equation x minus 4 times z minus 2 equals 0, and to graph the set of points. If we have a point x, y, z that satisfies this given equation, it's pretty easy to determine that it must have an x-coordinate that satisfies x minus 4 equal to 0, or a z-coordinate where z minus 2 is equal to 0. One of these two equations must hold for any point on in our set, and these two equations, of course, can be simplified to be x equals 4 or z equals 2. These are both planes. X equals 4 is a plane parallel to the yz plane, which is 4 units in the positive x direction that intersects the x-axis at 4, and z equals 2 is a plane parallel to the xy plane, which is 2 units above the xy plane. Therefore, the set of points that satisfy this equation will be the union of the planes x equals 4 and z equals 2. Here is a graph of this region. The red plane shown here is parallel to the yz plane and intersects the x-axis at 4. Therefore, it is the plane x equal 4. And the blue plane is parallel to the xy plane and intersects the z-axis at 2, and therefore is the plane z equals 2. The equation on the previous screen identified the set of points that lie on one or both of these two planes. Now, we want to describe the set of points that satisfies the equation y plus 2 times z minus 3 equals 0, and to graph the set. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. Any point that satisfies this equation must have a y-coordinate that satisfies y plus 2 equal to 0, or a z-coordinate that satisfies z minus 3 equal to 0. Therefore, the point must either have y equal to negative 2 or z equal to 3. Each of these equations represents a plane, a parallel to one of the coordinate planes, and can be seen here. Y equals negative 2 is the plane parallel to the xz plane, which intersects the y-axis at negative 2, and z equals 3 is the plane parallel to the xy plane that intersects the z-axis at 3. The set of points that satisfy the equation are the set of points that lie on one or both of these planes.